Which is a better predictor of processing speed in Intel microprocessors? Release date or initial release price?
Okay, so we're going to measure this by transistor count in microprocessor. So transistor count in each microprocessor is going to be our basic guide. So what we need to learn first is what a transistor is. Transistors aren't so interesting on their own, but are extremely interesting when formed in the structures of multiple transistors. This is because of a transistor's main function, which is they're essentially switches that allow for electricity to flow into a circuit board, controlled by a binary input determining their state of function. This means that an input given by a computer can determine whether or not the transistor is in an on state or an off state, allowing electricity to flow or not. Given this method of data input, a properly constructed grid of transistors can be used to form logic gates. As such, the more transistors there are, the more logic gates a computer can support, and the more processes can be computed at once.
So more transistors equals better performance. So which correlation is strongest? Transistor count versus release date or transistor count versus initial market price?
So in this spreadsheet, we have the first 17 processors ever made by Intel over on the left. You see, starting Intel 4004, ending at Pentium 4-seater mill.
We skipped some processors, some subdivisions, but that's not important.
So yeah, in the next column, you're going to see release date, which is one of the variables we're actually measuring to see which is better predictor of transistor count, and next to it is initial price. The dollar signs aren't actually on the spreadsheet, but you can just assume, as in the Intel 4004, we have an initial price of $200, and Intel 8008 has an initial price of $120, and so on and so on. Next, we have the actual transistor count itself, which starting at 2300 to 3500 to 4500, and so on, all the way up to that huge number at the bottom for the Pentium 4-seater mill. And then to the right of the transistor column, we have the logarithms of the transistor count.
So why do we log the transistor count? We log the transistor count because when we look at the transistor count versus date, we can see an exponential growth rate.
So this is the data we gathered transformed into graphs. On the left we have the release date variable, and on the right we have initial market price variable. So initial thing you're going to notice is just how the graphs look. The release date variable seems to have more of an exponential curve to it, whereas the initial market price variable is just extraneous. It's everywhere. On the left, for release date, you're going to see that the R value, the correlation coefficient, is going to be 0.62, which is a fairly strong correlation. However, on initial market price, we have a 0.06 correlation coefficient, which is incredibly weak. So when you get the square root of the release date, it's 0.62 correlation coefficient, you're going to get 0.39 for its variance. And over on the right, when you square the R value for initial market price, you're going to get a 0.004 for its variance, which just goes to show you just how much stronger release date seems to be of a predictor versus initial market price.
Now, there's still not that much correlation between transistor count and date because it looks like an exponential curve while we're trying to take like a linear model. So let's transform this to linear. So we can take the log for the transistors and find the log transistors over time, and we have a pretty straight linear graph. And we can see that the R value is 0.99, is strong linear correlation. And the residual plot shows that it's really, really close to the line of best fit.
So coming back to the scatter plots we've made here, we'll look at initial market price, and we're going to wonder why. Why is it just not correlated nearly as well as release date? So what we can gather from this is that over time, over the course of years, release date is going to be a much better indicator because as time progresses, technology advances, and the more transistors we can fit into a microprocessor, the better the processing power. Now, initial market price is going to be kind of extraneous, as you see here, because of mostly, or at least one of the factors of it would be due to inflation. So money back then versus technology back then is not going to be nearly as productive or as efficient in correlation as transistor count versus release date, which is why release date in this case is a better indicator of transistor count.
So to conclude, we can say that the transistor count, or the log of transistor count versus date, is a stronger indicator of, or the predictor of processing power. And this correlates with Moore's law, which states that observations over the history of computing hardware, the number of transistors in a dense integrated circuit doubles approximately every 2 years.